Good morning, sir. I'm Vaishnavi from CSC department. My topic is recursion with example program factorial of a given number. Introduction to recursion. Recursion is a programming concept where a function calls itself to solve a problem. It is a powerful technique used in many algorithms and data structures. In this presentation, we'll explore recursion through an example program calculating the factorial of a given number. What is factorial? Factorial is the product of an integer and all the positive integers below it. It is denoted by the exclamation mark. For example, 5 factorial is equals to 5 into 4 into 3 into 1, 2 into 1 is equals to 120. N factorial is equals to n into n minus 1 into n minus 2 into and so on into 1. 1 factorial is equals to 1, 2 factorial is equals to 2, 3 factorial is equals to 6, 4 factorial is equals to 24, 5 factorial is equals to 120. Recursive approach to factorial calculation. The factorial of a number n can be calculated using a recursive function. The base case for factorial is when n equals 0 or 1, in which case the factorial is 1. For any other value of an n, the factorial can be calculated by multiplying with the factor of n minus 1. Recursive function. Factorial. A recursive function to calculate the factorial of a given number. The function will take an integer n as an input and return the factorial as an integer. We'll name the function factorial function. Recursive factorial function. Compute n factorial using recursion. N greater than is equals to 0, int factorial int n, int ans semicolon. If n is equals to 0, answer is equals to 1. Else, redefine problem using recursion. Answer is equals to n into factorial n minus 1 returns answer. Code structure. The factorial function will have an if statement to handle with the base case. If n is 0 or 1, the function will return 1. Otherwise, the function will make a recursive call to itself with n minus 1 and multiply it with n base case. In the factorial function, the base case is defined as when n equals 0 or 1. When n is 0 or 1, the function will return 1. This is necessary to stop the recursion and prevent an infinite loop. Recursive call. When n is greater than 1, the factorial function will make a recursive call to itself. The function will call factorial n minus 1 and multiply the result within n. This process will continue until the base case is reached. Give a recursive algorithm for computing n factorial, where n is a non-negative integer. Use the recursive definition of the factorial function. Procedure. Factorial. If n is equals to 0, then return 1. Else return n into factorial n minus 1. 3 factorial is equals to 3 into 2 factorial. 2 factorial is equals to 2 into 1 factorial. 1 factorial is equals to 1 into 0 factorial. Initial case 0 factorial is equals to 1. Example calculation. Let's calculate the factorial of 5 using the factorial function. Initially, the function will be called within n is equals to 5. The function will make a recursive call with n is equals to 4, then n is equals to 3, n is equals to 2, and finally n is equals to 1. Recursive call stack. As the factorial function makes recursive calls, each call is added to the call stack. The call stack steps keeps track of the function calls and their parameters. Once the base case is reached, the factorial values are calculated and returned one by one. Recursive call unwinding. Once the base case is reached and the factorial values are calculated, the recursive calls start to unwind. The factorial values are multiplied together as the function calls return. Finally, the factorial of the original is obtained. Example program. The recursive call starts to unwind with n is equals to 1, which returns 1. Then the factorial of n is equals to 2 is calculated as 1 into 2 is equals to 2. The factorial of n is equals to 3 is calculated as 2 into 3 is equals to 6. Benefits and limitations of recursion. Recursion allows for elegant and coincide code in certain scenarios. It can solve complex problems by breaking them down into similar subproblems. However, recursion can be less efficient in terms of memory and time complexity compared to iterative solutions. Best practices for recursion. Always define a base case to stop the recursion. Ensure that the input parameters are properly updated with each recursive call. Avoid excessive recursion depth to prevent stack overflow errors. Conclusion. Recursion is a powerful programming concept that allows functions to call themselves. It can be used to solve various problems and is particularly useful in algorithms and data structures. Through the factorial, for example, we have seen how recursion can be applied to solve a specific problem. Thank you.